All right, so I want to talk about how to solve a problem like this. I call these constraint trig questions. So, given that tangent of an angle, tangent theta, is negative 5/4, and cosine of the angle is positive, find sine and find secant. Okay, so this is just a variation of the types of questions that you did, way back in actually like 1.3. Okay, so the first thing that I want you to sort of write down, in your notes, okay, I want you to draw out an x and a y axis here, and I want us to think about sine, cosine, and tangent, those ratios, right? And I want us to think about, in every single quadrant, are those positive or are those negative? So for example, in quadrant 1, the sine of any angle in quadrant 1 is what, right? It's positive, right? I'm going to just draw these a little bit different. So I'm going to write sine, cosine, and tangent. Okay, in quadrant 1, the sine of any angle there would be positive because the sine is the y value, right? And in quadrant 1, the y values are all positive. The cosine of any angle in quadrant 1, well, the cosine is the x value. So in quadrant 1, all the x values of all those points are also positive here. In tangent is like y divided by x. It's like the sine divided by the cosine. And since I'm taking a positive divided by a positive, the tangent would also be all positive in the first quadrant. Okay, so I just want you to think about if these things would be positive or if they would be negative. Okay, so let's write the same thing in all 4 quadrants. Okay, so in quadrant 2, the sine of any angle in quadrant 2 would still be positive. The cosine now would be negative because the x values of those points in quadrant 2 are negative. The tangent would also be negative because I would be taking a positive divided by a negative, which in total is a negative. In quadrant 3, the sine would be negative, the cosine would be negative, but the tangent would be positive again. And in quadrant 4, the sine would be negative, the cosine would be positive, and the tangent would be then negative. So just thinking about, from a general perspective, if I have an angle, wherever that angle lands, like if I'm going around the circle and I think about my sine, my cosine, my tangent values, those values, are they going to be positive or negative, and in which quadrants, right? Also remember the reciprocal functions. So, for sine, that would be cosecant. Cosecant, of course, would be the same signs as the sine. It's reciprocal. Secant would have the same setup as cosine, and cotangent would have the same setup as tangent. Okay, so I want you to think about that as we go through this problem. Okay, so then if you haven't written down this problem, right, go ahead and write it down. Okay, so it says, given that the tangent of an angle is negative 5/4 and cosine is positive, find the sine and the secant. In this problem, we're not given an angle. We're not given find the tangent of pi over 3. So we're not going to use the unit circle necessarily here. Okay, we're not going to just pull that out and use it. We're just going to go back to our right triangle SOHCAHTOA roots, right? So let's think about this, right? The sine of theta is negative. So we could say to ourselves, all right, theta, where is theta going to be, right? If I drew that out, the theta would be, in which quadrant? Well, we know that the tangent is negative, because negative 5/4. So tangent would be it's either going to be in quadrant 2 or it could be in quadrant 4, because you can see that tangent is negative in either 2 or 4, right? So there's a little bit of an ambiguity here, right? Is theta over here or is theta over here? There's kind of like two answers, right? There's two places I could draw this triangle here. And so that's why in this problem, in order to get a consistent answer, there is more information. It says, oh, by the way, if you're looking for theta, oh, it's also positive. Theta is greater than 0. So now when we're debating and thinking about, where would theta be? Right? Would it be here or here? Well, it's saying it's not going to be in quadrant 2 because cosine is negative over here. It has to be in quadrant 4, okay? Because the cosine is positive over here, right? All right, so, if I draw this out, and I just kind of draw a y and an x, I know that theta is going to be, it's just somewhere over here, okay? So there's theta. And what I'm going to do, I don't have a unit circle here, but I'm just going to stop this at some point, and I'm going to create my own right triangle in quadrant 4, because I know theta is in quadrant 4. So I'm going to make my own right triangle. And I don't know where theta is. It could be this. Theta could be this. I mean, who knows? I just know that it lands right in quadrant 4. We also know that it's exactly -5 over 4, right? We know the ratio. So we have to think about SOHCAHTOA, right? The tangent of theta is the opposite over the adjacent. And it just told us that the opposite is -5 over the adjacent of 4, okay? Now remember, we talked about reference angles. So wherever theta is, the reference angle to theta is definitely going to be like right here. So we're going to label this triangle as -5 and this as 4. Now we know this doesn't really make sense if we drew out a triangle to have a distance of -5, because distance is never going to be negative. But since we understand the idea of coordinate points, right, and we're in quadrant 4, that means that this, consider this to be a point right here at the end. This point would be 4, -5 or something like that. So I'm still going to put these values on the edges, the two sides of my triangle, just so I can understand this problem, okay? And so now we have, we drew our triangle, we understand it's in quadrant 4, and we put the information, we put the opposite over the adjacent on the triangle, and what we're trying to do is find the sine of theta and the secant of theta. So let's go ahead and do that. The sine of theta, okay? So no unit circle here. Let's just go back to SOHCAHTOA. That would be opposite over hypotenuse. Well, I have my picture here. The opposite of my angle is -5 over the hypotenuse, which I need to find the hypotenuse. I got to go back and just do the Pythagorean theorem, right? So let's just call this x, I guess. And let's do the Pythagorean theorem to find that hypotenuse, just like we did when we first started SOHCAHTOA, right? So this would be 4 squared plus 5 squared. It's really 5 squared, right? But I can put -5 squared because that's still going to be a positive, equals x squared. So 16 plus 25 equals x squared. So this is 41 equals x squared. And therefore the hypotenuse, if I take a square root, would be the square root of 41, right? So this value right here is root 41. Okay. Now when we think about that hypotenuse, okay, when we think about this right here, we're always going to think about that hypotenuse, or that radius. If we think about kind of unit circle terms, we're always going to think of that as positive. The only things that can be negative in this setup would be the possible x or y values, right? And that depends what quadrant we're in, okay? But anyway, going back to solving this problem, right? The hypotenuse is root 41, so now I can solve my question. It's -5 over root 41. And of course, if I'm going to get rid of the square root, then this will become -5 root 41 over integer 41. There's my answer to that. So that's kind of a long explanation, but you kind of have to understand the context of what all these little things mean, okay? We're really just using, right triangles, doing SOHCAHTOA, Pythagorean Theorem, and answering that question, but we do we do have to understand these little constraints here as well to see the big picture, okay? But what is the secant, right? The secant of theta, let's figure that out. If I go to SOHCAHTOA, the secant is the hypotenuse over the adjacent. It's the reciprocal of cosine. The hypotenuse here in my picture is root 41, and the adjacent is 4. So root 41 over 4 in this problem. All right. Now if you're still watching here and want to try another one, let's just try another one, and we can do that a little bit faster now. All right, so here we go. Problem says if cosine of an angle is 8 over 17, positive 8/17, right? Evaluate the other trig functions for theta if tangent is negative, right? So now understanding our constraints, we would think about this and we would say, all right, if theta is, if the cosine of theta is positive, well, that means that theta is either going to be in quadrant 1 because cosine is positive here, or it could be in quadrant 4 because cosine is positive here. These are my two options, here or here. The extra piece of information says that the tangent, however, the tangent of theta is going to be negative, right? So if I'm debating between, is it 1 or 4, it's going to be 4 here because that's quadrant, the tangent is negative in quadrant 4, not in quadrant 1. Okay, so now we sort of established that theta is in quadrant 4, and so we're going to go ahead and draw out a little triangle and figure out what our answer is. Okay, so theta is down here somewhere. Right, I'm just going to go ahead and draw a triangle just to have some information here. Right, I'm just going to draw a triangle, and I'm going to say this right here is theta. That's at least the reference angle to theta. Right, that's theta prime. And now I look at my information, and the cosine of theta, remember the cosine is adjacent over hypotenuse. We know that this is 8 over 17. So now looking at my setup here and looking at my triangle, the adjacent is 8. So 8, and the hypotenuse is 17. So the only thing we don't know here is the opposite side of that triangle. So we're going to have to use the Pythagorean theorem to find that opposite side. So let's go ahead and do that. So this would be 17 squared equals 8 squared plus, and let's just call this x squared. So this would be 289 equals 64 plus x squared. And we would subtract 64 from that, so we'd get 225 equals x squared. And if we take a square root, x would be the square root of 225, which equals 15. Okay, so now this is where we have to really understand the picture here. Okay, in reality, when we take a square root, right, when we solve this, it could be plus or minus. I didn't put that in there, but it could be plus or minus, right? The principal square root, the positive one, is just 15, but this could be plus or minus. So we could still think about this solution being negative. So when we write our answer right here, okay, we know that distance is 15. However, because we're in quadrant 4 and we're going down here, I'm going to consider this to be negative 15, right? Not positive 15, because if you think again of the coordinates and the point, so let's just say if we put, this little point right there, we're in quadrant 4. So this point would be 8, negative 15. The y value has to be negative there. I'm in quadrant 4, right? So I wouldn't put that as a positive 15, because otherwise my triangle, what I'm really doing is saying the triangle is up here, when it's not. It's in quadrant 4. So that's really, really important as we do this problem, right? So now that's our setup. That's our picture. We know it's in quadrant 4 and we have all the sides. So once that's set up, right, then we can evaluate all the other trig functions. So let's go ahead and do that. So what would the sine of theta be? Well, the sine would be opposite negative 15 over 17. The sine is going to be negative, right? The sine has to be negative. Cosine we already have. The cosine is a positive 8/17. The tangent is opposite negative 15 over adjacent, which is 8. The cosecant of theta would be the reciprocal of sine, so negative, and then 17 over 15. The secant would be 17 over 8, and the cotangent would be negative, and now we're going 8/15, so the reciprocal of that. And that's what we do. Okay, so again, these constraint questions really kind of revolve around first understanding where sine, cosine, tangent are positive and negative, and understanding what quadrant you're working in, and then doing SOHCAHTOA type of things, doing the right triangle stuff that we have already used before.